Good morning, children. Last class we have understood what is a rational number and how you plot the irrational number. Do you remember? I gave you various examples of how to plot root 2, root 3, root 13, root 7, root 29. Okay, and I also gave you a supporting video. In case you didn't follow, I have given you a supporting video in which they have shown by animation how the plotting is to be done. Clear? Now we continue with the next topic, and that is about rational numbers. Which numbers are actually called rational number? We have already learned the definition that numbers which can be expressed as P upon Q are rational numbers. But suppose if a real number is given to you, how will you identify that it's a rational number? Let us take up an example and understand it more clear. Here is an example about 10 divided by 3. Now in primary classes you have divided 10 by 3, and you find that if you divide 10 by 3, you keep on getting 1 as a remainder. No matter how long you keep on dividing it, you will get 1 as a remainder. Which means your answer would be 3.333. So 3.3 recurring, which you show with a dot. Okay. The second situation is 1 you are dividing by 7. 1 cannot be divided. So 0 point and then you put a 10 over here. So 1s are 7. 3 is remaining. 30. 4s are 28. This division you know. Am I right? Now here you find that you keep on dividing, you extend it further, and you come to a stage where 50 minus 49 1. Once you get 50 minus 49 1, it means that again this entire sequence will be repeated, because now it will be 10 and 10 means again 1s are 7. So this much part 0.142857 keeps on repeating again and again. So I can express it like this: 1 upon 7 is 0.142857. Now all these numbers are going to be repeated. You can check it if you want. As many times you continue division, this sequence will be repeated. So you draw a line above it indicating that this is a recurring part. 0.142857 is recurring when you divide 1 by 7. A third situation, 16 you are dividing by 9, in which 9 ones are 9, so 7 is remaining. In 70 you put point, you make it 70, and then 7s are 63 and again 7, which means now this will keep on repeating. Am I right or not? 7 means again you put 70 and 7s are 63. So 7 keeps on repeating, 1.7 keeps on repeating, so your answer would be 1.7 recurring. All these three situations wherein 10 divided by 3, 1 divided by 7, 16 divided by 9, where you get the recurring part is one type of rational expression. So rational expression stands for where the division is not terminated. Terminate means what? Khatam hona. When will the division be terminated? If you get the remainder 0. But you find that in none of these cases remainder is 0. You are not getting 0. So the division is not terminated. That means remainder is not 0, and the division keeps on continuing. Which means the P upon Q, that is this type of rational expression, is a non-terminating but recurring expression. Number keeps on recurring. Now let us take up another set of rational expression. For example, 40 divided by 5. 40, it's not 40, it is 4. Okay, 4 divided by 5 if it is given to you. Then 4 cannot be divided, so 0, and then you put 40 over here. So 40 divided by 5, you will get remainder is 0. So 4 by 5, 0.8. 282 by 3, 94 will be the quotient, and remainder is 0. 280 by 35. Okay, it's not 280, again it is 28. Okay, 28 by 5. You cannot divide, so 0.8. Okay, when you divide 28 by 5, you will get 0.8. Now, in all these three cases, you find that you are getting 0 as a remainder. So, when 0 is a remainder, it means that the division is completed. It is terminated. In that case, the answers are not recurring. आई बात समझ में? So, if P upon Q is terminating then and non-recurring, then also it is a rational expression. So rational expression can be of two different categories. One situation where the termination is not there, the division is not terminated, it keeps on continuing. So the answer would be recurring. So non-terminating recurring fractions and terminating non-recurring fractions, both of them are said to be rational expression. Did you understand? Which is explained on pages 9, okay, 9, 10, all these pages it has been explained. So we will take up a sum of this type from the exercise now. Here, exercise 1.3, I am picking up the first question. Now what is the first question in exercise 1.3? It says that before we move into exercise 1.3, I think the true and false on 1.2 is left out. So I will sum up that first. With that the exercise 1.2 will be over. In 1.2, the question is, you are having textbook, please open up. I will show you the question which is given in 1.2. Here, the true and false question which is given in 1.2 is, every rational number is a real number. Now, will it be a true or a false statement? It will be a true statement because real numbers, irrational numbers are numbers which are part of real number. So, every irrational number is a real number will be true. Real number is the largest set and irrational is a part of that real number. Secondly, every point on the number line is of the form root m, where m is a natural number. That would be an incorrect statement. On the number line, all the numbers will not be root m type, because if there is a negative number, on the number line you have negative numbers also, and negative square root of negative number is not possible. So therefore, every point on number line is of root m form is a false statement, where m is natural they are saying, and a number line contains negative numbers also, 0 also. So that would be a false statement. Every real number is an irrational number. That again is false. See, it is contradicting the first one. First one is irrational is real, but real number is not irrational, because real number includes negative, positive integers, 0, fractions, rationals, everything. But all of them are not irrational. अगर मैं 0 लिखूं, 0 is a real number, but 0 irrational नहीं है. If I write 25, 25 is a real number, but it is not irrational. Square root of 25 is not irrational. Did you understand that? So therefore, all real numbers cannot be rational, but all irrational numbers are real. Did you understand this difference? Okay. Now we move into the 1.3 exercise, where, as I just now explained, you have to give which decimal form is these divisions. So how will you work out? This is how you work out the sum. The first question is 36 upon 100. So you divide 36 by 100. When you perform the division, you will find that you get the answer 0.36 and your division ends in 0, terminating. So your answer will be 36 upon 100 is 0.36, and you will write that this expression is terminating non-recurring. The second sum in that section, 1 is divided by 11. Now when you divide 1 by 11, it's not possible. So you put 0, so this will become 10. 10 again is not going to be divided, isn't it? So again you put one more 0, and then the 10 is brought down, so it will be 100. Now when you divide this by 100, you will get again 1 remainder. So if you divide 1 by 11, you will keep on getting 1 as a remainder with 0.09. So what keeps on recurring? 0909 keeps on recurring, because now here 1 is there. So if I want to make it 100, I will have to put one more 0 and then by 9, 99. ऐसे जाएगा. Did you understand? So this 0909 keeps on repeating, and hence this is non-terminating but recurring. Understood? Same way sum number third. Third sum, you first convert into mixed fraction, 33 upon 8. But when you divide 33 by 8, you divide and see it. Okay, now I am not showing it like that. Division you know. When you divide 33 by 8, it is exactly divisible. 4.125 you will get. Okay. Whereas 3 by 13 if you divide, you will find that if you divide it, the division is not complete. You will get 0.230769, means this sequence gets repeated again and again. Just check it out whether you are getting it or not. Just as I showed you 1 by 7, same way you divide 3 by 13, you will get 230769. This sequence will be repeated. So this will be a number which is going to be repeated again. So it will be a recurring non-terminating fraction. Same way you are having 2 by 11. 2 by 11 if you divide, 0.18 will keep on repeating. So all this you have to divide and check whether you are getting the answer accordingly or not. Division is to be done as you have been doing in the primary classes. The last sum in that section is 329 by 40, but this is completely divisible. See, if you divide you will get 0 remainder and the answer will be 0.8225. So this will be terminating, non-recurring, whereas these two are non-terminating, recurring. This is again terminating, non-recurring. Did you understand? So when they say what kind of decimal expansion is it, you have to divide and then show it like this, that whether they are non-terminating and recurring or terminating and non-recurring. Understood or not? Okay. Now the second question which is given over here is 1 by 7 is 0.142857. Can you predict what the decimals of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actually dividing? Okay. They have given you that this is the answer of 1 by 7. So now they are asking you, without performing division, find the expansions of 2 by 7 till 6 by 7. So what should you do, you know? Yes. See. 1 by 7 answer is already given to you. If I want 2 by 7, I have to multiply numerator and denominator by 2. Isn't it? Sorry, I have to multiply this fraction by 2. So I have multiplied this side by 2. So I will have to multiply this also by 2. So 2 by 7 is 1 upon 7 into 2. So this value is to be multiplied by 2. So I will get this answer. For 3 by 7, I have to multiply this 1 by 7 by 3. So I will have to multiply this answer by 3. And that is what I get. Did you understand that? Similarly, can you work it out by 4 by 7, 5 by 7, 6 by 7? Can you try it out? Means you keep on multiplying this answer by 4, 5, 6, 7. Whatever value they are asking you, that you multiply, you will get the corresponding answers. Now there is a very interesting question which is asked. I am taking up the fifth one over here. What are the maximum number of digits in the repeating block of digits in the expansion of 1 by 17? Perform the division and check your answer, they are saying. Means you divide 1 by 17 and find out after how many digits will the number be repeated. So here I have performed the division a bit because I started in a very small space. 1 by 17 cannot be divided, so 1 you put a 0 and dot and then it becomes 10. 10 again cannot be divided by 17, so one more 0 I put, so it will become 100. Now 100 by 17 will be 5 times 85. Okay. Remainder is 15. 150 it will be 8 times. Like that I have performed the division. I have got 0, 5, 8, 8, 2, 3, 5, 2, 9, 4, 1, 1, 7, 6, 4, 7. I repeat. 0.58823529411764 This is how the complete division has been done by me. See, 160 by this part is not complete over here. This has been repeated over here. See, 160 minus 153 is 7. That part I have rewritten away because here there was no space. So I have rewritten over here and then I have continued the division. Finally, I will get 1 over here. Did you get it? 120 minus 119 is 1. And when you get 1, it means again you go back to the initial condition. 17 is to be divided by 1. Sorry, 1 is to be divided by 17. That is what you will get. So that means after this sequence, which sequence? 0, 5, 8, 8, 2, 3, 5, 2, 9, 4, 1, 1, 7, 6, 4, 7. This entire thing will be repeated. This entire thing will be repeated. How many digits are there? You just count and see. There will be 16 digits after the decimal which will repeat if you are dividing 1 by 17. Did you understand? So, this is what has been asked in that question. So, with that, I have explained about 3 types of sums, 3 questions which are based on what I explained today. Question number 1, question number 2 and question number 5. These 3 are to be written from this exercise for the time being. The next type of sum when I teach, I will take up the remaining sums from this exercise. Clear?